Hello, everyone. It's 4:45, so let's get started. Welcome to continuous integration and deployment using SaltStack. Hope everyone is in the right room. Unlike my flight attendant who announced upon landing here that welcome to Denver. So a little bit about me. I'm a SRE manager. Yes, the hateful word manager. Previously a Linux sysadmin. I'm currently working at Pure Storage. In the past, I've worked at Motorola and Yahoo. So I have some experience in doing CI/CD, and I thought I'd share that with you guys. I've been using SaltStack for about roughly 2.5 to 3 years right now. I'm really pleased with it, and I wanted to share some of the things that we have done with it. So in the next 45 minutes or so, what we'll be talking about here is defining what CI/CD is, the architecture of CI/CD, deploying to a cloud using SaltStack so that you can implement CI/CD, testing your application code, and doing rollbacks or roll forwards. The intended audience for this talk are people who are somewhat familiar with SaltStack, and would like to use SaltStack to implement a CI/CD environment. And you're probably using one or more of these clouds, or you could be using another cloud. You don't have to be using a cloud, but you need some way of provisioning hardware other than submitting a PO and waiting for 3-4 months for the hardware to get in. It's a lot easier if you can sort of spin up infrastructure on demand. So let me just stop here, and if you guys have any questions, please feel free to interrupt and ask. You don't need to wait until the end. I want to do a quick survey here. How many of you are using public cloud? Just raise your hand if you are. Okay, a majority of you are. That's good. So how many of you still need to wait 2 to 3 months before you get hardware? 2 guys. All right, 2, 3 guys. All right, so for you, I don't know what you'll do. But hopefully you have some spare capacity that you can use to deploy. Because I think it's really important to have the ability to define infrastructure as code and to be able to bring it up on demand. And having access to a private or public cloud lets you do that. All right, so what is continuous integration? There are a lot of different definitions for continuous integration. The one that I liked the most, or the one that I thought was the most relevant to me, was the one that was on ThoughtWorks website, which is continuous integration is a development practice that requires developers to integrate code into a shared repository several times a day. So you have a developer that sort of checks in code into Git, and that triggers a Jenkins build, which then outputs some sort of artifact, in this case, a Debian package if you're using Ubuntu or Debian. But this is what I define as continuous integration. Does anyone have a different definition of continuous integration? We haven't talked about CD deployment or delivery yet, but what do you guys think about this definition of continuous integration? Does it make sense to you, or yes? Makes sense? Okay. Git is by far the most common source code control system that I have seen and I'm familiar with, so that's the one I'll be referring to. But you may be using something else like SVN, God forbid, or Mercurial, I'm not sure, something else. But that's fine as well. You don't need Git as long as you have some sort of source code control system. And Jenkins is also by far the most common build automation tool I've seen used, but you could be using something else. You don't have to be using Jenkins. This is just something that I've used, and that's why I'm sort of sharing my experiences with you. What other build automation tools do you guys use besides Jenkins? Travis? Sorry? Electric Cloud. Bamboo? Anyone? TeamCity? Okay. Yeah. Any of those will work, but I'm going to be talking about using Git because that's what I know best. So that's continuous integration. So what's continuous deployment? Continuous deployment is also known as continuous delivery. And there are people who will tell you that continuous delivery is not the same as continuous deployment. They're both different things. To me, they're the same. I'm sure people can make a case that they're not, but regardless, with respect to this talk, CD is the practice of deploying code into production after it's passed through CI and tested in staging. Now, staging to me is pre-production. Staging to you may not mean pre-production. So when I say staging, I mean an environment that resembles production. So for some people, there's actually 4 stages in the pipeline. There's development, staging, pre-prod, and production. Some people just sort of combine staging and pre-prod into one, and that's what I'm doing here. So you take that artifact that was the output of this CI system. You take this artifact, and then you push it into some sort of staging or pre-prod cloud, and then from there, after adequate testing, you push it into production cloud. The CD definition, you guys agree with, don't agree with? Any thoughts on that? Yes? Mostly heads nodding, so okay, good. Yeah? Validation or testing is definitely part. Should happen yes, definitely it should happen in the staging cloud or pre-prod before it goes to production. So part of this perhaps this definition should include validation before it goes into production. Good point. Thank you. Okay, so why use CI/CD? Besides the fact that it just looks cool when you say, oh yeah, we use CI/CD, and you probably get more hits on your LinkedIn profile if you put CI/CD expert. Why would you want to use it? Because it reduces the delta between staging and production. Before we implemented CI/CD, a push to production could have taken, let's say, 1 month's worth of developer check-ins were compressed together and then pushed into production. So that meant that when we were on call, we were troubleshooting 1 month's worth of Git commits, which was horrendous because we just didn't know what broke and when it broke. But now with CI/CD, every change gets pushed. So there's really, if something breaks, it's just one change we need to troubleshoot. So it's a lot easier on us. So that's why we can catch issues sooner as well. Also, we have better insight into which code check-in broke the environment, primarily because instead of having like 20, 30 check-ins, now there may be 10 check-ins, right? So if we're pushing with every check-in, if 10 developers, let's say, push in 10 minutes and that gets deployed, there's a lot fewer things for us to troubleshoot. Reduce issues arising from integration. Developers are forced to sort of do unit tests with CI/CD, and part of CI/CD is having integration testing, and that's why we come across fewer issues with integration, thanks to CI/CD. And above all, we have happy customers in the end because things break fewer times, or if they break, we can quickly fix them. Another big plus, I think, that has happened is developer productivity has increased a lot, because in the past, when we were not using CI/CD, we had to involve developers in troubleshooting production issues, but now we don't necessarily have to involve them because there are so few changes that we can easily troubleshoot and figure out, which means developers can spend more time doing what they're supposed to do, which is code. Any other advantages you guys think CI/CD would provide, or what are your thoughts on this? More stable environments. So CI/CD pushes more, so there are more changes. So how do you think that makes it more stable? Less changes at one time, right. So there are fewer changes. The delta is smaller, but you're pushing more often. So the stability, I agree with you. Stability is definitely something that improves. Even though you're making more changes, you're making them one at a time, right?
You get a more consistent and predictable outcome.
That's right. So most development teams work use some sort of agile, like they use Scrum or Kanban or Lean. And if they're using Scrum, they usually have what's known as a burn down chart, a sprint burn down chart. So they try and accomplish some predictable amount of workload in a sprint. If the sprint is 2 weeks, let's say they accomplish 20, 30 story points as they're called. So you get a more predictable rollout to production, like you've said. And that's one more advantage. Yeah. Yeah. That's right.
So if something breaks, says I didn't change anything, roll back to your previous version, see if that fixes it. Roll back, it fixes it. All right, so what did you change?
Right, that's right.
You go back and compare your latest versions and find out what they changed.
Right, that's right. So the point here being developers who commit code and claim that they didn't break the build, it's easier to pinpoint that they did break the build because it's their code that got deployed in the last production push. So that makes it easier to figure out really who was responsible. Thank you. You had a point?
Yeah, I think you have to codify more of your infrastructure and automate more in order to get there. So,
Yes. That's right. So there's two components. One is application CI/CD, and the other one is infrastructure as code. So infrastructure as code is important to CI/CD. It's not required, but it is important to it. Yes. Okay, so what are some requirements for CI/CD? Number one, you need some sort of revision control system. You need build automation like Jenkins, Bamboo, TeamCD, whatever else. You need some sort of monitoring. I hope you're not using Nagios. Anybody using Nagios? Only three. Okay. So yeah, every year the number of people who raise their hands in similar conferences keeps going down when I ask the same question. How many people are using Nagios? We're using Datadog, and you need some sort of way of deploying a provisioning infrastructure automatically. And most of you raised your hand when I asked in the beginning if you're using a public or private crowd, so that's a good thing. We also use Datadog because we didn't want to manage our own monitoring software. Datadog is a software as a service infrastructure monitoring provider based out of New York. Yeah. There are alternative solutions. Some of you mentioned these before: Travis CI, TeamCD, Bamboo. I haven't used them, and I won't be talking about them. But I'm wondering, for those of you who use this, have you integrated these in Salt, or do you use these as a replacement for implementing CI/CD, or have you integrated them with Salt?
I've seen cases where they do deployment with Bamboo. Not necessarily right.
Okay.
That's the right thing, but when organizations that have a development mindset, developers want to control everything.
Right.
They know how to deploy the code. They're going to do everything.
So you've seen environments where people have used Bamboo to do deployments. Okay. Builds and deployments and everything. Okay.
Bamboo slaves.
Okay.
Basically doing the deployment.
Bamboo slaves doing deployment jobs. Okay. Yeah.
Not Bamboo, they used ThoughtWorks,
GoCD, that's right. So ThoughtWorks has a commercial solution, right, called GoCD. They have open source. Okay. So that. Okay.
And then you want to allow the developer to use as many processes they want to build, so they have the option to do either like Jenkins,
Right.
or no build server, but then that would be consumed by the CD software.
Right. So you want to allow developers to use as many build tools as possible, and the output of that can be consumed by the CD process. Yeah.
We started out with Travis CI. Recently moved to Circle CI.
Okay.
In conjunction with Salt, working out fairly well.
Okay. So you were using Travis CI, and then you moved to Circle CI, but that you're still integrating that with SaltStack. Okay. So yeah, so these are tools that can integrate with SaltStack as well as some people have shared. So it's possible. So bootstrapping an environment. So I want to make sure that we separate out these issues. One of them is deploying your application code using SaltStack. The other one is bootstrapping your environment. Remember earlier that I had mentioned that I'm talking specifically about about application code. But you can use SaltStack to bootstrap your environment as well, of course. And what we do is, let me come on this side. We use CloudFormation. So given a vanilla Amazon account, so if you give us a blank Amazon account, we can spin up our entire infrastructure in it. So we use CloudFormation initially, which uses JSON templates. It brings up a network in Amazon, which is a VPC, and it brings up a single AWS EC2 instance, which is a Salt master. And then SaltStack then contains all the definitions needed to bring up the rest of the infrastructure. So SaltStack brings up elastic load balancers. It brings up RDS. It also brings up DynamoDB, S3, SNS, SQS. SaltStack has a module for Amazon called Bodo. So we can bootstrap and bring up our infrastructure using SaltStack, which is really helpful.
Where do you keep your salt formulas when you bootstrap the master?
So the question is, where do we keep our salt formulas when we bootstrap our masters? So CloudFormation is painful to use, but it has ways of injecting things in the EC2 instance after it's come up. So we do that, and then what we do is we have a Git server that contains all the formulas. So CloudFormation will get the EC2 instance to talk to Git, and then once, and we use GitFS. Yeah. So with SaltStack, we use GitFS. I know some people may have a cron job running on the Salt master that downloads the Git repository, but we use GitFS. Yeah. Yes.
How do you execute your CloudFormation template?
So how do you execute CloudFormation templates is the question. If you're bootstrapping an environment, then somebody manually is doing it. And yeah, so for an SRE or a developer who wants to bring up an environment will basically bootstrap by going into AWS console, and in CloudFormation there would be a template that he or she would click.
Are you using Salt and Jenkins for that?
No, yeah. Any other questions on this? Yes.
Talk about stage and production environments. Are both those environments in the same?
Yeah, so the question was staging and production, are they both brought up this way? And yes, they're both brought up this way, yes.
But they're separate.
They're separate and completely separate Amazon accounts. They're not just separate VPCs, but they're completely separate accounts.
Salt master for each environment.
Yes, so we have a Salt master for each. We have a Salt master for staging, a Salt master for production, and they're not just in separate VPCs, they're in separate AWS accounts.
Probably has different salt formulas, versions of salt formulas for each environment.
So we try and keep Salt code as common as possible between them. What's different between the environments is the pillar data, and the mine data is, of course, different between them. But we try and keep a lot of the formulas the same. Yes. Yeah?
The last step, you're using like Salt Cloud and then like proxy minions, or
We're not using proxy minions, no.
how are you figuring the ELB?
So SaltStack has an ELB Python module, right? So you just use that to configure it. So the Python module SaltStack has are really helpful. There's like a bunch of them, and we use them extensively. No, no.
So what's the advantage of using Salt Master to provision all these other AWS components on the right versus doing it in a CloudFormation?
Yeah, so the question is, what's the advantage of using SaltStack to provision AWS resources versus getting CloudFormation to provision the resources? And the answer is, have you ever looked at a CloudFormation template? So thank you.
That's what it is. Can you also find dependencies, right, with salt? So orchestrating is
Yes.
easier. I haven't used CloudFormation, but I'm assuming orchestrating.
Yeah, with SaltStack, orchestration also makes it easier, which CloudFormation doesn't have. Yeah.
Do you at this point in time have your last step independent of infrastructure? And if so, how would you provide that information to Salt Master? Like, hey, I'm using AWS, I need to do different actions here instead of different things, load balance or different things.
So the question is, how do I provide information to the Salt master about which load balancers to spin up and all?
What
I wanted to have the third step be infrastructure dependent, like do the same stuff but on DigitalOcean.
Okay, yeah. So, so the question is, if you want to bring up this infrastructure, not in Amazon, but like in DigitalOcean or whatever. So SaltStack, and I'll talk about that coming up, has different drivers for cloud. So yes, you can make it makes it easy enough that you just install, reference the driver for DigitalOcean, and then it'll bring up those instances. Yeah. Yes.
Do you use any auto-scaling features? I mean, do you use maybe auto-scaling groups on AWS, or maybe you mentioned auto-scaling uses beacons and the SaltStack reactor?
Yeah, so the question is, do we use any auto-scaling groups, and do we use beacons and reactors? We do use auto-scaling groups. Unfortunately, those are not as automated as we'd like them to be. So we use SaltStack to bring up the auto-scaling groups. We're looking at moving away from them and using reactors and beacons so that everything is within SaltStack, but we haven't gotten there yet. Yeah.
Other issues where, let's say you deploy CloudFormation, you get Jenkins, and also master start provisioning your ELP suite, like Amazon RDS example, some kind of state formulas and version.
So the question is, are there any dependencies that come up before or after that cause things to stay?
Something related to dependencies, basically, so let's say if a bunch of some particular state fails in the middle of provisioning the rest of them,
Right.
how do you clean it up? Let's say you
Yeah.
created some load balancer,
Right.
some load balancer cannot link
Right.
How do you do from there?
So the question is, what happens if your state fails, and how do you clean up? Because let's say I'm provisioning ELB and RDS and DynamoDB, but RDS fails, but the others succeed, right? And how do you clean up? And cleanup is not one of the strengths of SaltStack, I think, because there's no way for us to roll back and start from scratch like CloudFormation provides. So right now, it's a little bit of a manual process, which is we look at what failed. And I'll talk a little bit about monitoring states. What we do is we monitor states using Datadog. So if a state fails, we get a page saying a state has failed. So we use that, but it's a manual step, yeah.
So should it be there first then, and then SaltStack at the end, like move that whole block from the top to earlier?
Moving this block to before SaltStack? No, because SaltStack is bringing up all of this.
You can't roll back.
We can't roll back, but that doesn't mean that this block moves before Salt Master. This just means that the part that failed, you just figure out why it failed, and you run that salt state again.
Then you can't automate it.
It's still in code. You're just debugging why it failed. This is all of this is defined in SaltStack as code. You're just sort of figuring out why that state failed. Yeah.
Briefly to his point, if you're logging all the data, if you're logging all the salt transactions, what you can do is you can use the salt reactor when the event fails to send an event that says, please reset all of the components right back to pre-test conditions, and then you can start over and run the test again. That's how we solve the problem. We have harvested all the data, all the logs up to the Salt server, all of the salt states in there, the output and standard out and standard error.
So just to repeat what he said, one way of solving the figuring out what broke and rolling back is to monitor salt logs and then have a salt event that triggers a rollback. That's another way. We haven't tried that, but that's a good way, yeah.
One other way is to use something called troposphere. It's basically a library of CloudFormation.
Right.
Provided with Python, so it's not painful, so it's something JSON.
Right.
And then all of that
Yeah, so I just found out about troposphere this morning in somebody's presentation. So the comment there is use troposphere that makes easier for you to deploy CloudFormation. Yeah, thank you. Yes. How many masters? So per environment, there's one master. Yeah, yeah. All right. So the deployment responsibilities that we have distributed in our environment basically are the network CloudFormation brings up, as I told you, and it brings up one Salt master, and then SaltStack brings up everything else after that. So that was bootstrapping an environment. Let's talk about what the expectations from the teams are in terms of best practices. Basically, teams should be taught to check in code frequently. You shouldn't wait for a day or two. As you code, you do some unit tests and you check in code. They should respond to alerts from bad code pushes. You shouldn't ignore bad code pushes because then you may have 5, 6 alerts and you don't know which bad code push is responsible. They should build proper unit tests, have adequate integration tests, and move towards a microservice architecture if possible, because if you're troubleshooting smaller services, it's a lot easier to do that versus troubleshooting monolithic services. So what are we deploying? We're deploying application code, which is Java, Python, whatever else that we have. And we're deploying infrastructure, and we're doing both as code. So what's the difference between them? With infrastructure, we use Salt Cloud. How many of you here have used Salt Cloud? Raise your hand, please. Okay, not many. Salt Cloud is really awesome. It abstracts out deploying to a cloud like DigitalOcean or Amazon or Rackspace or whatever you have. So the state files just define the infrastructure, and then they spin up the infrastructure. Once the infrastructure is up, within the infrastructure, when a developer checks in code into some sort of repository like Git, Jenkins does a build, creates an artifact that SaltStack will then deploy. So there's 2 components. One is the infrastructure, and the other one is the application. Yes?
Is every artifact, is everything that comes out of Jenkins a Debian package? So like if you have a Java app, you're going to package it with Debian so you can use the Salt.
Yeah, so the question is everything out, whatever Jenkins is outputting, is that a Debian? And yes. It doesn't matter if it's Java or Bash or Python. Jenkins we make it a requirement that if you're a developer, you have to output a Debian. Any questions on this? Yeah.
For the second part, the application code, maybe we'll get to this. If you're testing branches, for example, before it integrates, you're going to want to spin up different infrastructure for that branch, test it out, and then kill that infrastructure, and then integrate the branch. Have you done that at all, where you're actually spinning up a cluster of machines on again, and then applying the application to that infrastructure all?
Yeah, so the question is, do we spin up infrastructure on demand and then apply application code to that infrastructure? We do spin up infrastructure and then apply code to it, but if you need new infrastructure to spin up, then you create the Salt Cloud map file for it and you push it out, and then that will cause your infrastructure to come up, and then you can run through this stage. So yes, there's 2 separate processes. One is you create the definition for creating that new infrastructure, the Salt definition, and then you push that out, and then you deploy your app on those.
Are you managing that through a reactor once your infrastructure comes up?
No, so we're not. So the question is, are we managing that through a reactor? And no, we're not managing that through a reactor. The way we're managing is once the infrastructure comes up, the infrastructure has a Salt minion installed on it, which knows which repository to go and download the Debian from and install it.
So it doesn't need a reactor.
It doesn't need a reactor.
It's just doing that Salt call.
Yeah,
Pushing it from Salt is just minion.
So the minion is just going out to the Debian repo and pulling it down. Yeah, and I'll show you that in the next slide here. Actually, wait, where is that? Okay, so yeah, I think I forgot to put the package repository over here, but 2 things are happening. Number one, once the developer does a git check-in and the Jenkins output is an artifact, that goes to a package repository. So we use a package repository called packagecloud.io, but basically you just need a web server like Nginx or Apache, and then you just need to add that as a repo on your host, and your host will go and download the RPM or the Debian from there. So you need to make a decision if you want to automatically promote to production or you want to have a manual developer sort of spot check, make sure everything is right, because this is really important. And the reason I say that is you really need to have extremely thorough unit testing and integration testing for this automated step to happen. Without that, what we found out was we were really eager to make CI/CD work, and my team's pager was going off a lot because developers didn't care if my team was paged. They were just sort of like, hey, it's going into production automatically, right? So we started to enforce more standards in terms of unit testing and integration testing, but then they started to not do as much as needed. So our pager volume reduced, but it was still there. So then we said, okay, a developer has to manually merge from the development branch, a staging branch, into a production branch. And that sort of helped because just the fact of them doing a git merge command made them think a lot about, hey, am I doing the right thing or not? Yeah.
So if I'm understanding correctly, there's really only two branches that you're doing this staging branch and production branch. You're not like, you don't have a different set of infrastructure for testing each branch.
There is a different set of infrastructure for testing feature branches, but we sort of have that in a development account. I'm focusing on staging and production. So there are feature branches with infrastructure testing in a development environment. I'm focusing more on the staging to production because CI/CD is more about that, yeah.
So if you validate something with staging and that works, you need to merge that branch to production.
That's right.
And then you rebuild again. So
Yeah.
you're using a different artifact because staging.
Yeah, so the question is, if you're in staging and you deploy an artifact to staging and then you do a git merge and you're triggering a new Jenkins build, you have a new artifact and you're deploying that to production. Yes, that's true, but in essence, they are the same because the code is exactly the same, but you're right, it is a different artifact. We wanted to, some of the new systems, the new things that we're doing, the artifact is the same, but right now it's different, but yeah.
So along that same line, what we did with that is they would build their package in Jenkins. It would go to actually two different environments.
Right.
A dev and an integration environment. If that succeeded, they would then merge that into the master on Jenkins, and re-push that up. It would still go through those two environments to make sure that it still succeeded on the test. So even though it's a different package, it still went through the same process to validate it.
Right, so another approach like you're saying is if you have two packages, the production package still has to go through the staging environment to make sure that everything works properly. So that's also another approach, yes. Yeah.
What we're actually doing is we use Rogan feeds.
Okay.
Little packages and we push to like our QA environment and load from the same package.
Okay.
And just basically do an automated install on the same code, same and test it that way as well.
So you use ProGit, you're saying, that enables,
So like make new Git files using Rogan, push them to a QA feed.
right.
Deploy the QA, get all that package from there, so it's very remote, just directly feed QA to UAT, which is the station. Deploy, test on that, and promote the package.
Yeah, that's right. So that's another way of doing it, which is taking that same package that went into staging and pushing that through UAT. Yeah, yeah.
Two small questions. First, so using Jenkins to trigger the build
Right,
deployment.
yeah.
So like if some developer needs to redeploy something to production or whatever, he needs to go to Jenkins and trigger the build. Okay. And second one is how does Jenkins talk to SaltStack? Just the command line or it's Salt API?
Yeah, so the question is, how does Jenkins talk to SaltStack? So the way we do it is, I'll answer your question in a minute, and I'll show you a slide that answers your question, which is, how does Jenkins talk to SaltStack? Basically, you have a Jenkins unit test job, and then you have an integration job, and then you have a build job. So the integration and unit test use the actual code to do the test and not the Debian package, but the Debian is built from the code, so it doesn't really matter. And then the Debian is pushed to a repository, a Debian repository, like Package Cloud, as I told you. So the Jenkins doesn't really talk to SaltStack at all. Jenkins talks to the package repository, which is packagecloud.io, but it could be any package repository. And once the package is in that repository, then the SaltStack minions, every 5 minutes, they check that repo and they ask, hey, is there a new package from me? Is there a new package from me? If there's a new package, you just download it. That's right, and I'll show that to you, yeah. So the question is, do we do package.latest? And yes, I'll show that to you in a minute. I'm running short on time. I've got like 10 minutes, so I'm going to plow through these, and you guys can sort of ask me more questions. But if you want to get one thing out of this whole presentation, it's this slide, basically. Just if you want to go back home and then implement CI/CD, just follow these steps, and you'll be able to implement CI/CD. I can't help you with the office politics and all of that. But sorry, there's no solution for that. That session? Yeah. So install Salt Master, install Salt Cloud. If you haven't done that, do that tonight. Salt Cloud uses Apache libcloud. Configure Salt Cloud to talk to your DigitalOcean or AWS or whatever else that you have. Define Salt Cloud profiles and providers, and then configure Jenkins to generate packages and then push those packages out to repo and download from SaltStack. So this is basically CI/CD in a nutshell. So how do we install Salt Master? There's a really good docs. The SaltStack team has done a really great job of updating the documentation. So just follow that. I copied some of that over here, but this is one way of installing Salt Master. I'm assuming most of you know this already by now. Configuring cloud providers. So when you install Salt Cloud, you need to tell Salt Cloud, hey, go talk to this cloud provider. You do that using a provider config file in etc saltcloud.providers.d. And over here, I've configured it for Amazon, so it's talking to Amazon. Notice I'm using, I don't have any keys over here because in Amazon, I'm using instance profiles. So Amazon has IAM roles, Identity and Access Management, that makes it easy. So my Salt Master has access to Amazon to deploy EC2 RDS DynamoDB without any keys.
But that's only if you're running it on an EC2.
If your Salt Master runs on EC2.
Yes, that's right, yeah. And then make sure you specify which version of SaltStack to install, Salt Minion to install, because normally this will just go to, if you're doing Ubuntu, it'll go to the Ubuntu Debian repository and download whatever version there is, which may be behind SaltStack. It usually is. Cloud profile is where you define the different types of instances that you want, like a web server, a database server, or an application server. It's pretty simple. You just sort of pick an AMI in case of Amazon, and you define the different settings for it, like the disk size and networks and all of that. Map files are used to define how many instances of a type you need to bring up. So if you want to bring up 30 web servers, a map file is used to list those. And then you run one command, basically saltcloud-m, which is the map file name, and -P to create those in parallel. That uppercase P is really important. If you forget those and you have, let's say, 100 instances, it'll spin them up sequentially. So, yes, that's right. So Amazon has API limits. So if you have a lot of instances defined in your map file, you'll hit API limits, and that'll cause the instance creation to fail. Your API limits are negotiable with Amazon. So if you reach your limit, you'll have to experiment and really figure out what they are. And then you can email their support, and they'll increase it for you. Any questions on providers, maps, or profiles? Yes, so the comment is you can template this to Jinja, so you can do like a for loop, and yes, you can. Thank you. Any other question on these three? Yeah? Yes? Can you tell it to batch 5 at a time? I don't know the answer to that. There may be a way. I'm not sure what it is. Sorry. Okay, so configuring Jenkins. Jenkins has a lot of cool plugins. This is a plugin that we use. So you had asked a question in the back, how does Jenkins talk to SaltStack? And this is how it does. It uploads the package to packagecloud.io, which is a Debian repository. And then SaltStack minion talks to that repository and pulls the package down. Yeah?
So this, I need to put this plugin here is to upload the package to cloud.io?
No, yes, this plugin here is to upload the artifact, the output of Jenkins build job, into a Debian repository. In our case, it's packagecloud.io. In your case, it could be a simple Nginx server.
So it supports like Yum too?
I don't know if this supports Yum, but there are a lot of Jenkins plugins, and you should try one out. Yeah.
So if your deployment process currently is something like deploy the code to all of your production servers.
Right.
And afterwards, you would like to do something like do a health check for each of the
Right.
production servers. And if at some point the health check fails,
Right.
you want to roll back.
Yeah, so the question is, you deploy to production. If the health check fails, you want to roll back, and how would you do that, right? So I'm covering that here in a minute. Let me get to that. I have a slide for you on that. But how do you configure Debian repos? This is basically a Debian thing in etc app sources.list.d. Just add a file that points to the repository. Like this one points to a Datadog repository for installing a Datadog client. It's pretty easy. How do you get Salt to run every 5 minutes? Because what we do is every 5 minutes, Salt will go and talk to the Debian repo and say, do you have a new package for me? Do you have a new package for me? Do you have a new package? We schedule a high state every 5 minutes using the Salt scheduler. This is in Pillar. We put this in Pillar. It gets pushed to all the clients, all the minions. Yeah?
So in this process of deployment, like you do essentially full file deployment, Jenkins pushes a package and then the server on schedule installs.
Right.
So how do you do something like a canary testing where you make a couple of servers first
Yeah,
and
that's-
see if it works?
So the question is, in this style where we upload an artifact to a Debian repo and then the Salt minions automatically download it every 5 minutes, how do you do a canary type of testing? And our canary testing is in pre-prod because our staging, because it's identical to production in all way and sense, really. If it works there is a 99% chance that it'll work in production. Now, having said that, we do use in SaltStack, there's something called batch deployments. So, and Amazon also supports code deploy. So we use both of those technologies as well to do canary deployments, where SaltStack will trigger code deploy, and code deploy will then only deploy to a small subset. And if those work, then it deploys to the rest. Yeah.
If you're running high state every 5 minutes, is this the same top file that we use to provision the entire environment as well?
So the question is, if we're running high state every 5 minutes, is this the same top file that we use to provision every environment? So this is a pillar top file, and it's the same for staging and production, yes.
So you show that you use Salt to provision your environment.
Right.
So install the package.
Yes.
Lay everything out. So this
Yes, so the question is, will high state be calling all the other states every 5 minutes? It will be calling the application states every 5 minutes. The states for defining the infrastructure are separate from it. It won't be calling it.
Two separate salt repos.
We have one salt repo. I mean, it's divided. Yeah. You could say they're two separate ones. Yes, the one for provisioning the infrastructure is a little bit different than the one that's used for after provisioning. Yeah, they're both in Git, but the ones for provisioning are not called every 5 minutes. They're only called when you bootstrap it. So when you bootstrap an entire environment, you point it to one. No, we point it to one repository, or one like directory in a repository, and we say we want you to bootstrap from this directory. And when we want to provision everything else, we point it to the other directory and say we want you to use this one, right? So how do we get the latest package? Again, this is how we do it. I think somebody mentioned it earlier. I'm going to breeze through the other slides in lieu of time. So testing your code, this is something that I want to. Our salt state testing really is not as good as I'd like it to be. There's test equals true, but that's not as good as what we want. I was hoping to come to the conference and learn from some of the other presenters on how to improve a salt state testing. And this morning there was a good talk on integration testing. So it was using a tool called SIT, I think, Salt. So we're going to try that out, but we haven't really done a good job of that. So rollback or roll forward, quickly to answer the question here. The way this works is rolling forward is basically fixing whatever is broken and applying a new version of the Debian. Rolling back is going back to the previous version of the Debian that was working. So what we do is we use rollback. Basically with rollback, in Debians you can freeze a package. It's called holding. So if a package is at version 5 that broke everything, we do a salt remote execution to deploy version 4. So you can do salt, command.run on version 4, and then we run apt mark hold at version 4 until we fix the problem. And then when we have fixed the problem, then we do apt mark unhold. And then it goes immediately to the Debian repository, downloads the latest package, and installs it. So this is how we do rollback.
How do you manage, what about database? What if you're...
So
runs tables?
yeah, so the question is, what happens if your new version of the app makes the database schema change? Then we order dinner. Because we don't know how to roll back database schema changes. It's just too much work. We just sort of, we plow through it manually.
We have an interesting solution for that because AWS it's a PHP app. We apply a schema change, but before we apply that, we check if there's any migrations.
Right.
We'll make a backup of that, upload it to an S3 bucket, run the schema change.
Okay.
So then we have something to restore back in case.
Yeah, so the comment here being one way these guys do it is they make a backup of the schema before, and then they deploy the new version if there's a problem. That old schema, which is in S3, can be redeployed. So yeah. Yeah.
How do you maintain your versions? How do you know that it's version 4? How do you know you need to go back to a certain version of your process?
So the question is, how do we maintain versions? So all the versions are in the Debian package repository because we use Debians. So Debian packages have versions. So we have monitoring that if monitoring breaks, we know what version it broke at. And in the package repo, we know which version is the one before that.
How do you tell Salt to know what version?
Oh, we don't. So we wrote a rollback script that Salt goes to the Debian repo, looks at the version that's deployed on the instance, compares it to the one in Debian repo, and then finds the one before that and assumes that to be the one that was working, and then deploys that.
So what if you need to roll back to something from a month ago?
If you want to roll back to something from a month ago, the rollback script that we wrote has an option that says rollback version, and you can give it a version number. Yeah.
So I assume we have two repos, one for staging, one for...
Yes, we have two repos, one for staging, one for production, yeah. You can use what?
You can also use signed packages.
Signed packages, yes, that's right, yeah. So I'm pretty much out of time. I think I'm 5 minutes over. My apologies for keeping you guys over. But these are the last two slides, really. So what went well? Developer productivity improved remarkably. So one real brief story I want to share with you guys. So I encountered a lot of resistance implementing SaltStack because there was a team that was doing Puppet. And so halfway through the project, some issue had come with SaltStack, and they came to this big meeting with like 20, 30 people and said, oh, we're not happy, and let's roll back SaltStack. And 15 developers all immediately said, no, we're not doing that, because it made such a huge difference in their productivity that they really loved it. So that went really well. Developer best practices improved because they now had to write more unit tests, they had to write integration tests, and the stability of our environment overall improved, which meant our customers were happier. So that's what went well. What could have gone better? Like I mentioned earlier, our salt state testing is not where it needs to be. Hopefully after this conference it will be. Keeping pre-prod and staging in sync has been challenging, but we have to do it. And if anyone sort of makes a change in one place and not the other, then we crack down on them. And then driving developers to do frequent check-ins was also something that we had to push because they weren't really used to that. So yeah, that's all I had. Any questions so far?
The way you use the salt and then check 5 minutes, it's almost like a Puppet.
So
Similar.
So the question is, the SaltStack running every 5 minutes and checking do you have a new package is almost like a Puppet run. It is push versus pull mechanism, and you can argue for both. I think there are good points to be made for both, yeah. Since you guys have waited so long, I'll share a joke with you. So and a hardware engineer, a software engineer, and I'm sharing this because I'm a manager, and a manager all go out to the beach, and let me go to my slide there. And on the beach, they find a magic lamp. So they rub the lamp, and the genie comes out, and the genie says, okay, I'm going to grant you 3 wishes, but since there's 3 of you, each one of you gets 1 wish, instead of each one of you getting 3 wishes. So the software engineer says, okay, grant me that I spend the rest of my life in Hawaii. So the genie snaps his finger, and he's off to Hawaii. And then the other engineer says, my wish is grant me that I spend the rest of my life in the Mediterranean, in France or Italy. So the genie snaps his fingers, and the second engineer is off. And the manager said, it's my turn now, and I want both of them back before lunch. So thank you very much.